Hi, in this video I will show you how we can create AWS EKS cluster using Terraform and CI/CD via GitHub Action. Okay, so as you see in my screen, I have a pictorial representation of this demo. Yeah, so let me explain you what this picture represents about my demo. Okay, so here as you see in my screen, right, I have two big logos. One is the GitHub account, the other one is AWS logo. Okay, so one is a GitHub account, which is big one, right? So under this one, I have but two more logos. One is the Terraform, which I represent as a GitHub repo, yeah, and also I have GitHub Actions, okay, through which I will be invoking my Terraform file, okay. So that's the reason I have kept purposefully these logos under GitHub account, okay. Similarly, under AWS is nothing but a dead end product where we are spinning off our service, right? That is the EKS service in this demo, yeah. So finally, the pipeline would look like this. Okay, so I have a Visual Studio Code where I would be developing my infrastructure as a code. Once I'm done with my infrastructure as a code, I will be publishing the code to my GitHub repo. Okay, and I have designed the GitHub action in such a way that it will be automatically invoke the respective GitHub actions. Okay, so yeah, so once the GitHub actions are invoked, then finally the image on EKS services will be created in the AWS accounts. Okay, so that's what the this demo is all about. Okay, so that's a brief pictorial representation of this demo. So let me quickly walk you through the code, and finally I will show you the demo of creating the service, okay, through the GitHub actions. Okay, yeah. So let me minimize this. So as you see in my screen, right now I'm in the Visual Studio Code. Okay. So so here I have my complete environment ready. When I say environment completely ready, I have the GitHub repo. Okay, I have a GitHub account, and that GitHub account have a GitHub repo. So in that one, I have the GitHub action folder, that is the .github backward slash workflow folder. Under that one, I have a Terraform apply and Terraform plan file as well. Yeah. So as the name being suggested here, so the actions will be done by the respective file in the same way. Yeah. Yeah. So that's a brief about the workflow folder. And finally, under the root, I have two Terraform file. One is the eks.terraform file. So this is the file which contains whole and sole definition of a complete demo, right? So it completely holds the logic of creating the EKS service in AWS account. Okay, so that let me put it in a separate point. Yeah. Similarly, I have a main.terraform file. So the main.terraform file is a file which contains the provider data. Yeah. So here you see, right? So I have the two providers. One is the belongs to US East location, and also I have the Terraform backend configuration data. Okay. So that's what about main.terraform file holds about. Yeah. So 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 as you see in my environment, so as you see in the screen, right? So I have the complete environment ready for your purpose. Let's say if you want to set up this kind of environment from the scratch, please do watch my previous video where I have explained everything in regards to how you can set up the your GitHub repo, GitHub account, GitHub actions, and GitHub secrets, and also how you can set up this Visual Studio Code. Please do watch my previous video where I have explained everything from the scratch. Okay, yeah. So with that note, let's directly jump to the code walkthrough of this demo. So okay, so right now, as I explained, like eks.terraform file is the file which contains the end-to-end explanation or end-to-end Terraform definition about how to create EKS cluster in the AWS account. Okay, so that's what this file does is all about. Yeah. So let me quickly walk you through this code as well. First one is the data block. Okay, so it is nothing but I'm just getting my cluster ID with this block. Okay, so henceforth it starts with the data, and the resource type is again AWS EKS cluster because we are retrieving the ID of the EKS cluster, right? EKS cluster, right? Yeah. And this is the variable inside this flower bucket block. We are giving the parameter, that is the name. Yeah. So we need this. Okay, we need the attribute, that is the cluster ID. So that's the reason I have given name equal to I'm a cluster ID. Yeah. Yeah. So what this? So let me tell you again. So this is the block which will retrieve the EKS cluster data. Yeah, and we will be consuming this block and down the code. Okay. Yeah. Similarly, I'm also fetching the cluster authentication data as well. Yeah. So this is the block which does that. One is again it's a data, and the resource type is AWS underscore EKS underscore cluster underscore auth. Yeah, and the variable name is again cluster I have given. Yeah. And inside this flower bracket block, we are giving the name, that is our EKS cluster ID again. Yeah, that's a parameter. Okay. Similarly, let's go to the next block. So next block, we are just defining the provider of the Kubernetes. Okay. So that's what this block does is all about. Again, we are setting the Kubernetes provider. So again, it starts with the provider, then the Kubernetes. Inside this, we are giving the parameter. One is the host. Okay, so host is nothing but it will be retrieved from the above data block. Okay, so as I explained earlier, that we will be consuming the EKS cluster, right? So this block is being used here, and where the endpoint is being retrieved by that. Yeah. Similarly, cluster CA certificate. The cluster CA certificate is again being retrieved from this data block. Okay, so this is the data block which will be consumed here. Okay, so that's why the reference is be something like this. Yeah, that is the data.eks cluster. Yeah, then the certificate. Yeah, so it's nothing but it's again, sorry, so this is again using the same thing. Yeah, so that is the cluster and the certificate authority, and we are getting the zeroth item of that, and inside that we are getting the data. Yeah, similarly token. So here you go, so we are using the cluster EKS cluster auth. So nothing but this data block is being used here in the token parameter. Yeah, so we are using the token of that one. Yeah, similarly load a config file, so we are making it as a false, and version is equal to 1.1. Yeah, so that's about the provider Kubernetes block. So let's go to the next one. Similarly, I'm also retrieving the availability zone data as well. So similarly, again, it's a data block, and this is the resource type, that is the AWS underscore availability underscore zone is the resource type. This is the variable. Inside this flower bucket block, we are not giving any parameters here especially. Yeah. Similarly, local. So I'm just declaring the local variable here, and the local variable is the cluster name. So this is the my EKS cluster name will be. Yeah. Okay, so the next one, so let me tell you that, so this is the first time that in my demo that I'm using the Terraform modules. Okay, I'm using the Terraform enterprise Terraform modules. Okay, so here you go. So to create the VPC, I'm using the Terraform modules. That is the built-in modules from the Terraform. Okay, so it's a big block which does the creating the VPC resources, which is required to spin up the EKS cluster. Okay, so that's what this block does is all about. Okay, so this is the block. So let me select you. Yeah. So yeah. So let me select it properly again for you. So yeah. So here you go. So it starts from it starts from 29 and ends at the 52. So okay, this is the code block which spin up the VPC in the AWS account. Okay, again, so as I explained, so this is a module, right? So the module which we are using is VPC module. Yeah, so this is the name of the module. Yeah, inside this flower bracket block, we are referring the source of the module. The source of the module again. Terraform AWS module. In that one, we are using the VPC, and then that is the AWS module. We are consuming it. Yeah, and the version is I have given 2.58.0. Okay, and the name of my VPC will be Kubernetes-VPC. That's a simple name I have given. Yeah, and the CID range of this VPC is something like /16. That is 172.16.16.0./16. Okay, and the zones. Okay, so then the availability zones is again pointing to the same availability zones data which we are retrieving above. Okay, and inside for this from this VPC we are creating multiple subnets. Okay, so we are creating a array of subnets. Okay, so one is the private subnet and the other one is the public subnet. Okay, so I'm just, these are nothing but the naming convention changes. Okay, but the subnets will be will be created in the same VPC. Okay, so for the private subnets I am creating the three subnet ranges. Yeah, so these are the ranges. Similarly for public I'm just giving these ranges. Yeah, then let's go to the next parameter, that is the enable underscore NAT underscore gateway. So that's where we are making it as enabled. Yeah, similarly single NAT gateway is also made as a true. DNS hostname is also made as a true. So this is the parameter which is we need for resolution purpose. Okay, that is name resolution purpose, we need these data. Yeah, similarly the public subnet tags, so the public subnet tags will be added here. So that's a public underscore subnet underscore tags. Okay, so again the Kubernetes cluster or cluster name, and this is the value, that is the shared value is been given there. Yeah, similarly ELB, so that is the elastic load balancer value is been given as a true one. Yeah, similarly we have the private subnet tags as well. So for the private subnets we are giving the similar kind of data as well. Yeah, So that's all about the VPC module information. Similarly, let's go to the EKS module. Okay, again it is a big block again, so which will create a EKS cluster. Okay, so this is the module code which will help us to create a EKS cluster in the AWS. Okay, again it's a module, and the this is the EKS variable. Inside this flower bucket block we are giving the required parameter. One is the source. Okay, the source of the EKS is nothing but AWS module forward slash EKS forward slash AWS. Okay, the version is 12.2.0. Okay, this is the cluster name. The cluster name is, again, I'm retrieving from the same local variable above. Yeah, and the cluster version is something like 1.17. Subnets. Okay, the subnets which I'm choosing for EKS cluster is the private subnets being used here. Yeah, and the VPC ID is nothing but the same VPC ID will be consumed here. Similarly, node group. Okay, so if you see the node group, yeah, so we are creating the T2.micro type of EC2 services for nodes. Okay, and the first node is something like this. Okay, we have only one node, so that is the desired capacity is 1, maximum capacity is 10, and the minimum capacity is 1. So, okay, so when the load is more, the node can spin up to 10. So that's what this definition means. Yeah, similarly, instance service, I'm just using the T2 micro. Yeah, and the right Kubernetes configuration. So I'm just telling the Kubernetes provisioning Terraform file to create the Kubernetes configuration file as well. So where to store that Kubernetes configuration? So to store in the same runtime environment, nothing but where this Terraform will be run, right? So there only the Kubernetes configuration file will be created. Okay. So now down the code, we are again, what we are doing is we are again we want to store that kube config file in a storage bucket. Okay, let's say. So that's the reason I have added the below logic, which will pull out that kube config file, and it will store it in a locally into the S3 bucket. Okay, because when Terraform runs dynamically in GitHub action, right? GitHub action is something machine which will be managed by GitHub, right? So we don't have any control over there, and we cannot get that file. Okay, so in that case, what we need to do is we need to dynamically copy that file and store in a S3 bucket, so that we can use that for our the future purpose. Yeah. So similarly, I'm doing the same here. So what I'm doing is I have the bucket. I have one already created bucket. So I want to get the information about that bucket so that I can use it down. Okay. So that's what I'm doing it here. Okay, using the data block, and it's again resource type, that is AWS underscore AS3 underscore bucket, and this is the variable. Inside this we are giving the parameter, that is a bucket name. So this is my bucket name. Okay, inside this bucket we are keeping that the above created kube configuration file. Okay, so this is the block which does that, and it is dynamically being created. Yeah, so again it's a resource and the AWS underscore S3 underscore bucket object. So this is nothing but we are creating an object inside the bucket. Yeah, and this is the variable inside this flower bucket block. We are giving the parameter. One is the bucket ID. Yeah, so this bucket ID is being referenced from the above only. Yeah, and the key is nothing but your file name. So the file name we are getting dynamically from above module. Okay, similarly the source will be parented to the with using the dot forward slash parameter. Yeah, so that's it. What it does is it will spin up a VPC, it will spin up the EC2 instance, and it will consume that EC2 instance to spin up the EKS cluster. Okay, and finally the kube config file will be stored in a S3 bucket. Okay, so that's what this code is all about. Yeah, so since the what I can say, since the EKS cluster spinning will take nearby 30 minutes, so that's the reason I have already ran this code in my GitHub account. Okay, I have the logs, so let me quickly walk you through the logs, and I will show you the EKS cluster being created. Yeah, so let's go to the GitHub account first. So this is my GitHub account. Yeah, so where I was explaining all about. Okay, so if you go to the GitHub account, so it contains two branches. One is the main branch and future branch one. Okay, so these two branches are being created for a certain strategy. Okay, certain simple strategy. Again, I would again recommend you to please do watch my previous video where I explained in regards to the branching strategy. Yeah, so then let me go to the GitHub Actions as well. So this is the GitHub Actions. Okay, so where under the GitHub Actions, as you see, I have the two workflows or two GitHub Actions. One is the Terraform plan infra Terraform hyphen plan hyphen infra hyphen plan. Nothing but it will run the Terraform plan to plan the infra plan. Okay, yeah. So let me open the plan stage. Okay, and let me quickly walk you through the plan logs as well. Again, I will always highly recommend you to study the logs so that you will understand how the Terraform works. Okay, that's the reason. I mean, that's how I have learned the Terraform as well. Yeah. Similarly, so here you go. It says that it's going to create multiple resources. One is the EKS cluster is getting created. Yeah. The EKS cluster auth is getting created here. The S3 bucket object is being created here. That's what the summary says. Okay. Similarly, EKS cluster. Yeah. And so finally it should be creating the a role as well, so required roles are being getting created. Yeah, it indeed it will do multiple tasks. Okay, so let's quickly walk down. Okay, it is attaching the policies, creating the policies, multiple policies are being created dynamically here. It's creating the security group as well. Okay, and yeah, so let's go to the final summary. So it's big. I mean, huge load of data will be created, huge load of services will be created. Okay, so that's the reason it will take half an hour. Yeah. So let's go to the plan. Okay, so the plan says that it's going to add 43 services, zero changes and zero rest. Okay, so that's what the Terraform apply will do if we apply this one. Okay, so I have already applied the Terraform apply of this plan already. So let me quickly walk you through that log as well. Okay, so I have the one more GitHub action, that is the Terraform hyphen apply hyphen infra hyphen release. Okay, so let's go to that GitHub action. Okay, which actually provisions the EKS cluster. Okay, Terraform plan is nothing but just a draft. It will give the summary. Okay, but that stage does not create the EKS cluster. Okay, yeah. So now so let's see the logs. Okay, how it has provisioned the okay, it has taken 20 minutes to run the Terraform apply command on my code. Okay, yeah. So that's the reason, to avoid the time consuming, I'm just directly showing you the logs. Okay, so here you go. It has successfully provisioned the VPC, IAM roles, the NAT gateway, role policies again. Yeah, too many policies. Then finally it has successfully provisioned the required infrastructure. Okay, so let me take you to there. Finally it says that the 43 resources are being added, zero changes and zero rest. Okay, so that's what we want, and it has successfully provisioned the EKS cluster in the AWS console. Okay, so let me show you that. So yeah, so what I did is, so let me take a step back. So what I did is I made this code change. Okay, so I have made commit, I added EKS.terraform file here. Okay, once the code is been merged here, so I will just make a commit and do upstream branch synchronization. Okay, once the upstream branch synchronization has been done, Terraform plan GitHub action will run. After studying the Terraform plan GitHub action, then I came to know that it is actually doing the required stuff. Okay, so then what I did is I went to the Terraform up, I went to the pull request and I created a pull request against from my future branch one to main branch one, and then merged the changes. Okay, then that has in turn invoked the Terraform apply stage, which in turn provisioned the required infrastructure in the AWS management console. Okay, yeah, or AWS account. Okay, so let's go to the AWS account and see if all the services are being created or not. Okay, yeah. The first one, let me quickly walk you through the S3 bucket. Okay, so as you see, right, so this is the S3 bucket which I was referring. So under that S3 bucket, I have the kubeconfig file has been created, which I can use for connecting to my EKS cluster. Okay, yeah. So that's what I have done this one for this one. So let me take you to the VPC and show you that if the VPC has been created or not. Yeah, here you go. So the VPC with the name which we have given there, right? That is the Kubernetes VPC has been created successfully, and the status is available. Okay, so now let me take you to the subnet as well. We should be seeing 6 subnets. Okay, so here you go. We have the 6 subnet with the name public and private. Yeah, with the combination of public and privates. Yeah. So that's about the VPC. So now let me take you to the EC2 instance. Okay. So currently we should have one EC2 instance running. Yeah. So here you go. We have one EC2 instance been running as of now. It's okay, but it can enlarge up to 10 instances. Okay, so yeah, so that's what. So currently it is been running. Yeah. Now let me take back to the dashboard. Okay. So we have the security group, we have the volumes, and we have the elastic IPs. Yeah. So all the required services has been provisioned successfully by running the Terraform apply. Okay. So finally, let me take you the container service dashboard and show you that our EKS cluster has been created. Yeah. So I'm in the ECS console. Yeah, that is the Elastic Container Service console. So then let me go to the Amazon EKS and see the our EKS cluster has been created or not. Yeah. So I'm in the EKS cluster dashboard, and here you go. So we have the EKS cluster been running now. Yeah. So it the status is active and it is running. Yeah. So yeah. So let me walk you through this one. So here are the workloads. Configuration. So configuration is nothing but it will explain all our configurations. Okay. One is the details. Yeah. And so then let me take you to compute. Okay. We have the nodes. Okay. We have the nodes. Okay. And the desired size is 1 and it will range from 10. Yeah. Okay. So this is the node group data. Okay. So we have the node group where we are keeping our nodes. Okay. Yeah. Which will range from 1 to 10. Yeah. So that's what this explains all about. Yeah. So here you go. The instance type is 22.micro, which we have used, and AMI is something is this is one. Yeah. And the Kubernetes version is 1.17, which we have selected. Okay. And finally, yeah. So that's it. So now, so what I do is let me quickly show you the other part as well. So this is the VPC, which has been attached to this EKS cluster. Yeah. So where we can see all our VPC data here. Right? Yeah. Similarly, authentication, add-ons, and the logging as well. Yeah. So that's it. We have successfully shown you that how you can spin up an EKS cluster using Terraform. Yeah. So now, before I wind up, so let me show you that the status of how you can check the status of the EKS cluster using AWS CLI. Okay, so here is the PowerShell CLI. Okay, PowerShell window, yeah, or PowerShell terminal where I have logged into my AWS account. Okay, using AWS CLI, then I am running the EKS cluster command. Okay, so this is the command which I ran here. Yeah, where the name is my EKS cluster name, and it has retrieved the status equal to active. Okay, so that's it. So that's it. We have successfully shown you everything from the scratch to end of how you can spin up an AKS cluster using Terraform, yeah, and doing the CI/CD task using GitHub Actions. Okay. Thank you. So again, finally, thanks for watching our videos. And also a kind request, please do subscribe my channel. That would really encourage me a lot. Okay. With that note, thank you. Thanks a lot.